that we did in acidic, and then at the very end we do one little tweak. So MnO4 plus SO3 2 minus goes to MnO2 plus SO4 2 minus. All right, break it into the two half reactions. Balance the major atoms, primary atoms, whatever you want to call it. Mn is balanced, Mn is balanced. Sulfur is balanced, sulfur is balanced. All right, then we balance the oxygens. So in the top one, I have to add 2 water molecules to the right side to balance the oxygens. Then I balance the hydrogens by adding protons to the left side. So 4H plus. And then we might as well stick with this equation. I need to balance the charges on this equation. So what side am I adding electrons to and how many? 3? 4, right? I'm adding 4? Did I do the math right?
And then the 4 has a charge negative.
Oh, thank you. See? Yeah, so obviously I made a mistake, but that's a good point. Charges matter. We have to be very careful when we're writing that. So yes, we're going to add 3 electrons to that side because 4 minus 1 is 3. We got to get it down to 0, so 3 more electrons. There we go. All right, then we move to the next one. Balance the hydrogen or the oxygens. Balance the hydrogens. What side am I adding electrons to? It has to be to the right side, but check your work too. This left side has a charge of -2. The right side has a charge of 0. So I had 2 electrons. Now you just have to make the electrons go away. How do we do that? You have to have equal numbers, right? I have 2 in this equation, 3 in that equation, so I got to turn them into 6. So this one gets multiplied by 3. This one gets multiplied by 2. I'm going to write them below here. So we're going to get and then just add them. Electrons go away. 3 waters cancel those. That's gone, and that's 2. All right, so that's. Does everybody get that? Everybody get to there? Okay, that's. We're good. So that's clearly an acidic solution because we have the protons here. Okay. So we want to make it a basic solution. All you do is you add hydroxyl groups to each side. Okay. Think of algebra. If you add it to one side, you got to do it to the other side. The reason we add hydroxyl groups is because, let me do it. So I want to get rid of the protons because that indicates that we're in acidic solution. So we're gonna use the fact that H plus OH minus will form what? Water. Okay. So we have two protons we got to get rid of. So I'm gonna make an equation. I just write it below. You just go 2 OH minus on that side. And what you do to one side, you have to do to the other side. So 2 OH minus. So what's going to happen is these two protons and these two hydroxyl groups will form two water molecules. So the new equation is going to be and then there's one final thing we can do. Sorry? Yeah. You've got one water on the right side, two waters on the left side. So you can simplify that. Essentially, that water will go away, and this 2 will go away. So the actual equation is 1 water molecule plus 2 permanganate plus 3 sulfates goes to 3 sulfites goes to 3 sulfates, 2 MnO2s, and 2 hydroxyl groups. And it's clearly in basic solution because we have an OH minus there. Okay? The way that my key will show it, and you'll see it in a sec, you can just ignore it and just look at the final thing, is I used to just say, instead of doing this 2OH group, I would just say, okay, I want these two protons to go, so I'd use this water equation. And just say, if I need these to match, I'm just going to have to multiply this all by 2. All right, and then add it together. It works out to be the exact same because these protons will cancel those protons. You're left with 2 OH minuses on this side and 2 water molecules on this side. So you get the exact same thing. It doesn't matter to me how you do it. If you want to just add OH to each side, enough to cancel out these, or you want to use the water equation, the hydrolysis of the water equation, that's fine with me. It doesn't matter. Okay? But just so you know, in my key, it'll show that step, but the end result is the exact same. Okay? So everything's the same up until this point. That's acidic balancing, and then to do it in a base, you just add OH minus to cancel out the protons. Okay? All right. Try the questions in the back, and I'll post those questions, and I'll post the key in the classroom.